right, here we go. So we are doing section 1.6. First thing we're going to talk about is a word that you've seen many, many times before. Tell you what, let me do this. Let's put a line here so I know how far I can write down so you can see it on the screen. Let's put a line across. Let's try this again. And right there should be a good spot. Okay, so I know where to write. Let's do this. The first word we're going to talk about is the word circle. We're going to talk a little bit about circle in this chapter. Just slightly. At the very beginning, we're just going to talk about what a circle is and a couple things about it. Later in this section, we're going to do a little bit more with circle. In fact, later on in the book, I don't know what chapter it is, but there's a chapter where the whole chapter, every section is about circles. The whole chapter is. So we're just scratching the surface today on circles. So let's just write the word down first, and then we'll draw a circle. I have a little thing on here where I can draw a circle. All right, let's just move it up a little bit. There we go. All right, let's just talk about a couple things on the circle, how to label it, what a circle is, and all that kind of stuff. You don't have to worry about the definition of a circle. I'll just read it to you just so at least you hear it. It says it's the set of all points in a plane that is a given distance from a given point. That's the key phrase right there. It's a given distance from a given point. Well, which given point? Whoops. Let's move that back. Let's do this again. All right. So what's the given point? What do you think the one point on a circle that's really, really important is? That point right there. And anybody, any idea what we're going to call that point? Okay, middle would be a good thing, but it's not what we're going to call it, but that's a pretty good guess. If I was right there in the circle, where would I say I was? I was in the center of the circle. Very good. Okay, and that's a key point to a circle, and we're going to call that the center of the circle. It's a point, so how do we label a point? With a capital letter. What if I drew a line segment from the center of that circle to anywhere? Remember what the definition is. It's a given distance from a given point. So what's the given point? The given point is the center. What's the given distance? Well, it's not like to here. It's not to here. Where do you think I'm going to go to? From the center where? To the circle itself. Exactly, okay? And we call that point, we call it on the circle. So this point right there, see how it's on that white circle going around? We call that on the circle. So that's a point on the circle. What if I put a point out here? Would I say that's on the circle? What would I say? Outside the circle. What about a point in here? That'd be inside the circle, okay? But a point right on the line itself, that's on the circle. A lot of people think of a circle as like a disc, right? With and then if you're on the circle, you're like in it. Well, that's not on the circle. It's the outer edge, all right? So if I'm on the circle, it's the outer edge. So I'll give that a point. We'll call it CB. All right. So we have a way to name the circle. You know how we name lines, we name rays, we name line segments. We did that kind of stuff. We named a point. Well, naming a circle, you're using just one letter. Which letter do you think it would be? What do you think the important letter is on this? It's C. It's the center of the circle. That's, I don't know if you could say the most important, but it's an important point on the circle. Probably the most important point on the circle is the center of the circle. So here's how we label a circle. So I wouldn't write the word circle C. I would write it like this. I would write a little circle, but then they put a little dot right in the middle of the circle. Some books just put a circle, don't put the dot. This particular book puts a circle, then a dot. All right? So this is circle C. All right? That's how we label a circle. Everybody got that? So we don't have to write the word out. We just put that little symbol, right? We've had symbols for all kinds of things. We had symbol for angle, right? We had symbol for line and all that other kind of stuff that we just talked about. All right. There's something else in this circle that we're going to talk about before we move on from the circle. Okay, like I said, there's not a whole lot we're going to talk about today about the circle. But one thing is that little line segment that I drew right there from C to B. You probably learned this before. No. From C to B, it's a line segment, and it's got a specific name in a circle. Somebody tell me. You've seen this before. You did this in elementary school maybe. Right? Definitely in middle school at some point. Clea, what do you think? What do you think from this little line segment from C to B? I'll give you a hint. Once I give you the hint, everybody will get it. It starts with an R. Radius, see? Everybody got it. So radius of a circle. So the radius of a circle is what? It's from the center to any point on the circle. Is there only one radius to a circle? Well, kind of, because the length of the radius is the same. But there's actually a bunch of different radius to the circle. And while I bring that up, let's put a D. So radius would be singular. So you have one radius. What do you think you would say if you have two radius? Is it radiuses? Is it just radius? Is it something else? Anybody heard that? It's kind of a weird word. It's probably a word you may not have heard before, but here it is. This is the plural. Whoops, got to put the A first. So it's radii. That's the plural. So if you have more than one radius, you call them radii. So right here we have two radii, and a radius is a line segment. So what would I call this radius right here that I'm circling? What would that radius be called? Radius what? Or line segment what? CB. Good. So a radius is a line segment. So if I was to write down radius CB, it's a line segment. So you put a line segment over top of it. There's another radius drawn here. What's another radius on this circle? Line segment. Say line segment CD. Right? You can't just say point D. You can't just say point B. You can't just say point C. If I ask you for the radius of that circle, you have to give me 2 points. Now, I don't have to call it CB. There's another thing I could call it. Pretty simple. We've talked about this. What else? BC. Right. You could switch the order if you wanted to, or you could have called this what? Line segment DC. It doesn't matter. You don't have to start at the radius. Most of the time we do, but you don't have to. All right? Everybody with me on that? We're going to talk about this later, but since we're on this topic, what if I extended this all the way to the other side of the circle? This isn't officially in this part. It's going to be later in the section. What would I call that from, we'll call it E. What if I, line segment EB, is line segment EB a radius? No, because it goes all the way across. Now it does go through the center, but we have a special name for that, and you probably know that one. If you know radius, what's the other word that kind of goes with radius? Now it's not circumference. Circumference goes all the way around the circle. Which one goes through the center of the circle? Again, I'll give you the letter and you'll all get it, I bet you. It's D. Diameter. There you go. All right. That's just free for you. We will talk about that a little bit later. But since we talked about radius, I thought we'd talk about diameter. That's all we're going to talk about today as far as the circle is concerned. We're going to talk about some other shapes, though, but not a circle. Everybody good with circles so far? Yeah. It's the very, very beginnings of what we're going to learn about circles. It's like, how in the world could we have a whole entire chapter just on circles? Well, we do. All right, there's a lot to know about circles. Such a simple, elegant little shape, okay? There's a lot to know about circles. It's pretty incredible. All right, here's another word that we're going to use a lot. And I keep saying this, but it's true. I don't just say it to say it. It's absolutely true because I've taught this so many years. I know what's ahead of you guys. You're going to use this word quite a bit the rest of the year, and that's called a polygon. Has anybody heard of that before? It's a polygon. You probably know of certain types of polygons, and we'll talk about those certain types of polygons just in a few minutes, okay? But I got this little thing right here that I can tap, and I can pick how many sides I want. See where it says sides right there? Right now it says 6, and so let's just make 6. So hit OK, and there you go. I've got a nice... Now, I could stretch it. I can make it skinnier. I can make it wider, like that. It doesn't really make any difference. I could make it, perfect, but anyway, it doesn't matter. But that's considered a polygon. Polygon can have a whole bunch of different sides, okay? It doesn't have to be this many sides. How many sides does this thing have? 6. It doesn't have to be 6 sides. I just picked one that had 6 sides, okay? So let's just talk about this, just generally talking about a polygon. It's made up, a polygon is basically, it's a closed figure made up of straight line segments, okay? That's what it is. It's closed. That means like this line segment doesn't come up here and this one come up here and there's a gap. So there's no gaps. It's all closed in, like a fence with no gaps in it at all, okay? A couple words that we need to know about a polygon. And one is the name of the line segment. So when we talk about a line, or when you talk about a polygon, that line segment is called the side of the polygon. All right? So I even asked you that question, didn't I? How many sides does this thing have? All right? So you knew instinctively, didn't you, that that meant the line segments. All right? So each one of these is called a side. All right? Now you also have another thing. It's where those two line segments come together right there. We've talked about this. It makes an angle, doesn't it? We've talked about angles before. Remember that the angles come together at a point. What was that point called? It was a word that you don't hear too often.
Endpoint.
No, it's not the endpoint. It is the endpoint of the rays, so you are right on that. But when two rays have a common endpoint, we give a special name for that common endpoint.
Okay.
It's close, very close. It's not vortex. Anybody remember now? Katie's looking up in her notes. Tell me if you find it. It's the rays when you talk about angles. And they come. It's not vortex. It's super close to that though. Vertex. It's vertex. Okay, and that's what this point is right there. That point right there is called the vertex. Not the first time we've heard vertex. Definitely not the last time. Okay, we'll be talking about vertex a lot throughout the whole entire year. That's why we're covering this stuff early on, because you're going to hear this stuff over and over and over again. All right? Everybody with me on that? Okay. So now, let's do this. Let's get into a little bit more specific types of polygons. Let's do another polygon. Let's put another polygon on here. So I'm going to click that, click that. Let's make it a different number of sides. Let's make it 5 sides. All right? So there's 5 sides. And what I'm going to do, stretch it out a little bit. Does anybody know the name? We're going to talk about this in a few minutes, but does anybody just off the top of your head know the name of a 5-sided polygon? There's a big building. There's a big building in Washington, D.C. Pentagon. That's right. This is a pentagon with 5 sides. But right now, what I'm looking at is this. Everybody watch. If I did this, remember those little tick marks? Yeah, Fem. Hexagon is 6 sides. We're going to talk about that in a second. We're going to have a whole list from 3 all the way to 12, and we're going to list all the names for them, okay? So we'll get to that in just a minute after I talk about a couple things here. So this particular polygon, this side is equal to this side, which is equal to this, equal to this, equal to this. Remember the little tick marks we did? This is a place where we're going to use it. That means that all of these sides are equal to each other. Okay? So all 5 of these sides are exactly equal. When all the sides are equal, we have a name for that. When all the sides are equal, we call it equilateral. Because lateral means sides. I remember when I played basketball, we did this drill where, probably do this in football too, I don't know, where the coach in basketball had the ball like this, he'd blow the whistle, and he'd move the ball to this side. You ever do that? You ever play basketball? Right? And you're in the defensive drill, right? And you go from side to side, right? You shuffle back and forth. You probably do that in football. Right? In basketball, that's what we used to do. We call that the lateral drill. All right? Why do we call it a lateral drill? Because you're moving what? Side to side. Exactly. So that's why we call it lateral. Everybody see that? So that's kind of how I remember it. So the equa is part of the word equal, right? So equal sides. So when all the sides are equal to each other, we call it equilateral. This would be an equilateral polygon. Okay? So when all the sides are equal. So what would we call it? So if I put a little arc here, what am I showing? I'm showing all the angles are what though? They're equal to each other, exactly. Okay, so all the angles are equal to each other in this particular one. So if I have a polygon where all the angles are exactly the same, and how do I know they're exactly the same? Because I have these arcs. Each one of those angles has one arc. Okay? That means if they all have one arc, that means they're all equal to each other. Okay? So if all the angles are equal to each other, It's very similar to this. Oops, got ahead of myself. We call it instead of lateral, angular. Very good. Equiangular. All right, so when all the angles are equal, we call that an equiangular polygon. All right? And you're going to need to know this because sometimes in the instructions for the homework, they're going to say this is an equilateral polygon or equilateral hexagon or an equilateral square or something like that, or quadrilateral, okay, something like that. So you need to know what that means. So when they tell you it's equilateral, that means that all the sides are exactly the same. So on this problem, on this particular thing right here, this pentagon, if I just told you one side, and that's it, I only told you that one side, could you tell me the other sides? Yeah, absolutely. They're all 5, right? Because they're all equal to each other, all right? If I said that angle was 135 degrees, could you tell me all the other angles? Absolutely, okay? Now, I could have, now watch this. I could have a polygon, a pentagon, all right, that, like right there. Are all the angles the same on that one? Are all the sides equal on that one? No, it's still a pentagon, right? It's still a polygon, but it's not equilateral and it's not equiangular. I don't know if I could draw one, but there are also situations where all the angles might be equal, but the sides are not equal to each other. There might be situations where all the sides are equal to each other, but the angles are not equal to each other. Okay? Just not very good at drawing those. But with this program, I can draw one that all the sides and all the angles are equal very easily. And we have a name for that one as well. All right? And this is really important because, again, we're going to have later on in the book, we're going to have a section, not a whole chapter, but we're going to have a section on things called regular polygons. And we're going to do a lot with that. Okay? So when all the sides and all of the angles are equal to each other, we call that a regular, okay, regular polygon. All right, so if somebody says it's a regular polygon, then that means all the sides are equal to each other and all the angles are equal to each other. I would probably guess that every single person in here, every single day, well, not every single, maybe every single day, sees a regular polygon. A stop sign. Very good. Okay? So how many sides does a stop sign have?
Like 5, 6, 7, 8, 9.
It could be any of those? No. I actually worked, if you listen, I'll tell you a quick little story. It's not that exciting, but, and you're all right, it is an octagon. Very good. Neil, did you say that? Yeah, it's an octagon. So listen to me, real quick story. When I was in college, every summer when I was in college, I had the same job, and I worked for DelDOT. You know what DelDOT is? Delaware Department of Transportation. I rode around in these orange trucks. You probably see these orange trucks going down the roads all the time. And my job was to fix the signs. All right, if a sign would get knocked over, people would call in all the time. And I was with a crew, usually one guy, sometimes 2 other guys, maybe 3 of us would go out. And our job was to go and fix the signs. So we had stop signs all the time. We didn't just do stop signs. We did all kinds of signs. But that was my job. So I was around stop signs for like 5 summers. I worked with tons of stop signs. Some smaller, some bigger. Some got knocked down and bent up and stuff, and we take them up, put a new sign in its place. That was my job for 5 summers. Okay? Yeah, you got to put the pole in the ground. Back then we used a what'd they call it? They had a cap and a sledgehammer. Okay, so you put this cap that fit on top of the pole. You know, was made so it fits on exactly on the pole. Then you'd have a sledgehammer and you'd pound it in, boom, boom, boom. And it could be if the ground was really hard. Please stop. So, well, it goes 3 feet in the ground. All right, I think maybe it goes like 2.5 feet or something like that. I think it's a 3-foot pole, but it goes like 2.5 feet. I mean, it goes pretty far in the ground, about like that. Right, and we used a sledgehammer. Now, after I finished working that summer, I think it was the summer after I finished, I saw these guys on the road, and they got these like jackhammers that plugs into like electricity, right? And it would you just hold it and go, and it would put it into the ground. But every summer, I was hammering. I even got pictures. Maybe someday I'll bring them in and show you the pictures when I worked for Del Dot. But that was my job. I worked around stop signs and other kinds of signs all the time. And so I was very, very familiar with the signs. So that's just a little story about a stop sign. So this is a stop sign is a regular polygon, all right? It's got all the sides are equal to each other and all the angles are equal to each other. Eventually, we're going to find out what that angle actually is. To every stop sign, we can find out what that angle is. We're not going to do that today, but we will do that eventually. All right, let's do this. Let me see what time we're at here. 30. Okay, 5 minutes. We can do this. This is what I wanted to get to anyway. So we're going to make a list of sides and polygons, and we're going to name. And a couple of these we've already talked about. And some of the ones we haven't talked about, you probably already know. All right? So if I have a polygon with 3 sides, what do I call that? A triangle. That's it. It's a triangle. A polygon is very general. Okay, a polygon could mean any number of sides. Could I have a polygon with 2 sides? Why can't I have a polygon with 2 sides? It won't be enclosed. That's right. If I just have 2 sides, there's no way I could get that to be enclosed unless they're right on top of each other, and then there's nothing in it, right? So, yeah, just be a line. Exactly. So, the smallest polygon I can have is 3 sides, and that's a triangle. Now, there's several different answers you could give me on this, but there's one in particular I'm looking for. And I've actually used that word today. Yeah. A lot of people would say square, all right? And technically, that is a name of a specific 4-sided polygon. Absolutely. But I want a general polygon. So everybody look up here. Neil? So a square, that's a possibility. What's another 4-sided figure? Rectangle, okay? But there's one that you probably don't ever use, okay? And that's the one that we're going to use right now. And we call it, and by the way, triangle, that prefix tri, what does TRI mean? It means 3. Means 3, TRI. 4, what's the prefix for 4? Quad, okay? So we call this a quadrilateral. Again, lateral means sides. Quad is 4 sides. Because you can have a quadrilateral that's not a square, right? You could have a quadrilateral that's not a rectangle. So any 4-sided figure we call a quadrilateral. We will talk later on about a square and about a rectangle. We'll do a lot about that kind of stuff. All right? Let's finish this up pretty quick. 5 we've already mentioned. What's 5 sides? No. Pentagon. It's a pentagon. It's a building in Washington, D.C. And it's a huge, huge building. And the shape of it is a pentagon. It's actually a regular pentagon. 6, somebody mentioned that earlier. What's 6 sides? Polygon is just general for any number of sides. It's not octagon. That was 8 sides, remember? What's 6? Somebody said it earlier. Say it. Hexagon. Very good. Hexagon. That's a fairly common polygon. 7's not as common. Depends what book you look at. But this one, I won't even ask about this one. They call it a heptagon. I've heard some people call it a septagon. I taught out of a book one year that called it a 7-gon. They just put a 7-gon. All right? Seems like you could do that for all of those. It'd be nice if you'd stop talking and you'd pay attention up here. Jamarian, I'm talking to you. Number 8, we talked about it already. What's that called? Octagon. So O-C-T-A-G-O-N. Octagon. What's something very familiar with 8 legs? 8 legs. Octopus, right? Why octa? Because it's 8. 8 is the prefix, or octa is the prefix for 8. 9 is something that you may not have heard of before. It's a non-agon. Non-agon. Right. Some of these you never heard of, and you don't really use them that often. 10, I'm going to have to, I ran out of room down the bottom here, so 10. Now, how many, if you go 10 years, what do they call that? A decade. So we're going to call this a decagon. That's right. It's a decagon. All right, so that's 10. 11 is definitely one that I had never heard of until I saw this. So this is, I wouldn't expect you to remember this one. It's a hen decagon. At least this book calls it. It's kind of weird. 12 is kind of familiar, a little bit. It's called a dodecagon. Dodecagon. Well, these are prefixes. They're probably Latin. Okay, and listen. These are probably from the Latin, I would guess. If you just a wild guess, I don't know. You could always look it up. But these are prefixes, and we put the gon after it because that's how many angles. When you start putting the gons on there, right? That stands for the angles. How many angles does it have? All right. So that's it. Okay, that's it for today. It's not it for 1-6. We've got a lot more to do. I'm not going to assign you anything, so no homework this weekend. You got a long weekend? All right, so no homework this weekend.